Alright guys, today we're going to look at the graphs of polynomials. We're going to look at different characteristics about them, and then we're going to graph them, we're going to analyze them, and look at also how to get your zeros from the graph also, okay? So the first thing we're going to talk about is your end behavior. Your end behavior tells you where your graph's pointing on the left and where your graph's pointing on the right. Is it pointing up? Is it pointing down? Okay, so if your degree is even, and your leading coefficient is positive, okay, so the number out front is positive and the highest exponent is even, then your graph is going to rise on the right and then it's going to rise on the left. Now, so then now this is how you will have to answer your questions, just like this box right here, okay? This is what I want when I ask you for the end behavior, one of these four answers, okay? So it says, if it is an even positive, then my x's go to positive infinity. Well, watch this. My x's are horizontal. They're going to positive infinity. And then my y's are also going to positive infinity. So it's just writing what it means. Your x's are going to positive infinity. So that's your domain on the right-hand side. And then your range on the right-hand side is positive infinity also. Now, your left-hand side is your x's are going to negative infinity, and your y's are also going to positive infinity. Again, if you look at the graph, x's to the left go to negative, and then if you look, the graph is pointing up, which is positive infinity for your y's. And f of x is just a fancy way to write y, okay? All right, next one is if your degree is even still, but you have a negative leading coefficient, then it's going to fall on both the right and left hand side, okay? So if you look here, as x approaches positive infinity, f of x approaches negative infinity. Excuse me. So as my x's go to positive, which is to the right, then my x's are going to go to the negative, which is down, which is what this graph does. And then it says if my x's go to negative infinity, which is the left hand side, my y's are going to go to negative infinity, which is some points down. So the left-hand side goes to negative x's, and look at the y's, they're pointing down. Okay? Next one you're going to have is an odd degree and a positive leading coefficient. That means that, so how I remember this is if you look, these both are even, right? And even means the same. Well, both sides are the same. They're both pointing up. Negative, both sides are pointing down. They're the same. They point in the same direction. And when it's positive, it points to the positives. And when it's negative, it points to the negatives because they're the same. Now, when I look at odd, odd means you're different, right? You know, something's odd, it's different, it's off. Well, my odd in behavior is going to be different when you're so my odd behavior is going to be different. One's going to point down, one's going to point up. See how they're pointing in different directions? That's odd to me. Okay, that's how I remember it. So anyways, so if you look, it says the right hand side rises, the left hand side falls. So that means my x's on the right hand side are going to positive infinity, and my y's are going to positive infinity. Well, if you look, as my x's on the right hand side, which are positive, my y's are still positive. It's going up. Okay? Now the next one, the left hand side, is x's go to negative infinity. My y's also go to negative infinity. Well, if you look, x's are negative over here. My y's are also negative over here. Okay? Odd negative means we're going to fall on the right and rise on the left. Okay? So if you look, it says as my x's get positive, my y's get negative. As my x's get positive, my y's are getting negative. As my x's get negative, my y's will get positive. When my x's are negative, my y's are positive. Okay? So that's end behavior. Alright, so next we're going to talk about turning points. Turning points are just your curves in your graph. So when you learned quadratics, you were told there was either a max or a min. You couldn't have both. But when you get into higher polynomials, you will have both. Okay, so there will be a relative max, a relative min, and you will have your ultimate maximum and your ultimate minimum, but you'll have some little minimum and maximums there. So your turning points, so say you have a graph right here, and you have a polynomial on it, okay? This is what my polynomial looks like. The turning points are where it literally turns, where it's a max and a min. So my turning points here are 1, 2, 3. So I have 3 turning points. All right. So it says a polynomial function has a degree of n. So we talked about the degree. The degree is the highest exponent. So it says the maximum number of turning points is n minus 1. So if your degree is 3, it's only going to turn 2 times. Well, I have 3 turning points here. So if we reverse this, see how it equals the number of turning points? So if my turning points are 3, then that equals n minus 1. Add 1 to both sides. So the degree of the function I just drew is 4. So you can go backwards, okay? If you're looking at the equation, you subtract 1 to get your turning points. If you're looking at the graph, you add 1 to get your degree, all right? And then here are some steps of how to graph your polynomial function, what you do first. And we're going to get this all from Desmos, but then I want you to actually draw it, okay? So find the real zeros and y-intercepts of the functions. So Desmos gives you that. Plot your x and y intercepts, so you're going to find them, then plot them. Make a table. We'll just get a couple points from Desmos when we're looking at the graph. Plot those points. Determine your end behavior so you know where to put your arrows. Is your arrow going to be up? Is your arrow going to be down? That's what your end behavior is going to do, but also Desmos can show you that. And we're going to sketch the graph, okay? All right, now we've talked about multiplicity, but I want to talk about what that multiplicity means for the graph, okay? So if you have an odd multiplicity, so if you have x equals 1 with a multiplicity of 1, then that means at 1, my graph will cross the x-axis. So see how it's crossing right here? It's like crossing the street, okay? So when I see a graph cross through the x-axis, then I know that is an odd multiplicity, okay? Now, if you have an even multiplicity, that means if I give you x equals 2 multiplicity of 2, that means at 2, my graph will just touch the x-axis. It's going to touch it and then turn back up. See right here, it touches it and then goes back up. That is an even multiplicity. Okay, so if it crosses, it's odd. If it touches, it's even. I like to say don't even touch this, and that's how I remember it. All right. So here I want to talk about the leading coefficient, and I want to talk about the degree and the graph comparison. We're just going to sketch the graph based off of what we know, and then I'm going to state what the end behavior is. Or no, the graph comparison is going to be the parent function. No, we're not doing that. Okay. All right. So the leading coefficient. The leading coefficient is the number with the highest exponent. Okay. So this is my leading term right here. This has the highest exponent. If it's in standard form, it should be the first one up there. So the leading coefficient, the coefficient is the number in front of the variable. So my leading coefficient here is 4, which is positive, right? The degree is 7, which is odd, okay? So this is a positive odd. So a positive odd odd is going to be right here. All right, so that means as x approaches positive infinity, y also approaches positive infinity, and as x approaches negative infinity, f of x approaches to negative infinity. So we come down here, and that's what we're going to write. We're going to say as x approaches positive infinity, f of x also approaches positive infinity. And I'm just copying exactly what's up there. And then as x approaches negative infinity, f of x approaches negative infinity. You always write your x's first, but it really doesn't matter which one you write. I could have put negative infinity up there first. All right. So your next one, the leading coefficient, is going to be the highest exponent. So there's your leading term. So my leading coefficient here is negative 7. Okay, which was wrong. So my leading coefficient here is negative 7, which that makes that a negative, because remember in behavior we just want to know if it's positive or negative. My degree is 6, which is even. So I need a negative even. So a negative even. So a negative even. Let's change colors so you know. So a negative even is right here, and it's positive, negative, negative, negative. Okay? So as x approaches positive infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches negative infinity. Remember when I said it's even? When it's even, your y's are going to be the same. See how they're both negative infinity? And have you noticed that I'm using the same x's each time? The only thing that's changing is what my y's doing. So this right here is standard for all 4 of the end behaviors. You're just changing your y's is all you're doing, okay? So this one, here's my leading term. So I have a negative 2, so that makes my leading coefficient negative. And then my degree is 5, which makes it an odd, okay? So I go up here and look for negative odd. Negative odd is right here, and that says x approaches positive infinity, y approaches negative, and then as x approaches negative infinity, y approaches positive infinity. Okay, so I come down here and I'm just going to write that, and I'm going to say the same thing. As x approaches positive infinity, f of x approaches negative infinity. Then this one, as x approaches negative infinity, f of x approaches positive infinity. Okay? All right, now we're going to look here to find the degree and the leading coefficient. All right? Now, you can find the degree 2 different ways. You can find the degree by doing the turning points plus 1. So the one way to find degree would say turning points plus 1. So I have 1, 2 turning points, and my degree is 3. Now, the other way you could find it is looking at the end behavior. So if you look, as my x's are negative, my y's are negative, and as my x's are positive, my y's are positive. So I go up here. As my x's are negative, as my x's are negative, so as my x's are negative, I done forgot it. So, okay, so as my x's are negative, my y's are negative, so it's the same. X is negative, y is negative, x is positive, y is positive. So I need them with the same thing. And the one who has the same thing is going to be right here. Okay? So that means that I have, so when you look over here, that means I'm going to have an odd positive. Okay, so an odd positive. So an odd positive means, so my degree is odd. See how it's 3? That's odd. We found that already. And my leading coefficient is going to be positive. All right, we can do the same thing over here. You can find your turning points. 1, 2, 3. So I have a degree of 4. Look at the end behavior. Both my y's are positive. Okay? So both y's are positive, so let's look for an in behavior with both y's positive. And an in behavior with both y's positive are going to be right here. And so that means I have an even positive. So my leading coefficient is positive again. Alright, again over here, degrees, count your turning points. 1, 2, 3, 4. So it's 4 plus 1, so we have a degree of 5. Leading coefficient, we're going to look at the in behavior for this. So my x's are negative, my y's are positive. My x's are positive, my y's are negative. So this is opposite. So I need somebody who has opposite looking at the in behavior. And the people that have opposite is going to be right here. See, my x's are positive, my y's negative. X's are negative, y's are positive. So I have an odd negative function. And we've already found that it's odd. Now we just found that it's negative. Okay? So really it's just looking at that chart is what you need to do. Okay? Now, that is all in standard form what we did up here. Okay, so we did this in standard form. Now we're going to do it in factored form. Okay, so this is factored form. Alright, so when we do factored form, it's a little bit different for the degree. Okay, because you can't just look at the highest exponent, you have to add your multiplicities up to find your degree. So to find a degree in factored form, you have to add up the multiplicities. And we've already talked about that. Those are your exponents, okay? Those are your multiplicities. So if you look here, we're just going to skip there for just a second. I have a multiplicity of 2 and an understood multiplicity of 1. So 2 plus 1 would be 3. Okay? All right, solutions. We've been talking about this. Your solutions are right here. Okay? This is written in factored form, and you just have to solve. I'm going to show you how to solve the first one, and the rest of them you should just be able to look at. The first one, we would say x minus 1 equals 0. Add the 1. X equals 1. So all you're doing is solving for x. So one solution is x equals 1. Then we're going to say x minus 3 equals 0. You add the 3. You get x equals 3. So we have two solutions here. Now, the x-intercept, your x-intercept is your solutions. Okay? But in coordinate form, we'll write it in coordinate form. It's going to be 1, 0. So if it asks for a solution, it wants x equals. If it asks for x-intercept, it wants it in coordinate form. And then my x-intercept is 3, 0. Multiplicity for each 0. The multiplicity is the exponent. So multiplicity for 1 is 2. Multiplicity for 3 is 1. Okay? Graph that. We're not going to graph here. We have a section of graphing. Okay? So your leading coefficient is the number out front where there is no number. So it's an understood positive 1 because there's no negative symbol. So my leading coefficient is 1. Graph comparison, that's who does it compare to? So you're odd. So it's a degree of 3. We're going to compare to y equals x cubed. In behavior, we've talked about that up there. There is a little shortcut down here. So this is an odd positive. So an odd positive is going to be odd positive is where my x's and my y's are the same. So they're both positive and they're both negative. So I come down here. And, oh, you got to pick which one it is. So this is where they're the same. So it's going to be C and F. C and F. So C and F down there. Okay. If that confuses you, don't worry. I'm just finding using box 1 right here. Okay. Instead of me having to give you all that room up there to write. Okay. Maximum number of turning points. Remember your turning points formula is n minus 1 where your n is your degree. So 3 minus 1. So my turning point should be 2 when I graph this function. Okay? Solutions. You do not have to do anything with that 1/12. That 1/12 is what is your leading coefficient. So I'm going to go ahead and write it over there. Now your degree is your multiplicities added up. So 2 plus 2 would be 4. So that's my degree. Okay. Now I'm going to find your solution. So x plus 2 equals 0, and you would solve, and you would get x equals -2. You do the same thing for the next parenthesis, so x would equal +3. Coordinate form, multiplicities. So this has multiplicity of 2, and this one also has a multiplicity of 2. We're going to skip the end behavior. I've hashed it enough. Turning points is your degrees minus 1. So I have 3 curves in this graph. Okay. Last one for this. Okay. Oh, I know what I skipped. So I skipped and if it touches or it crosses. So if it's an even multiplicity, remember, don't even touch this. So that means it's going to touch and odd crosses. Here, this is going to touch. This is going to touch. My bad, guys. And I got that from out here. So if the graph crosses the x-intercept, is an odd multiplicity. If the graph touches, it's an even multiplicity. Okay. So this problem right here. Now we haven't gone over when x is just by itself. X by itself, again, you can solve it. So x just equals 0. There's nothing to solve there. So one of your zeros is x equals 0. Your other one is x equals +3. And your last one is x equals -2. Okay? So the multiplicity, write it in intercept form. So it'd be 0, 0, 3, 0, and then -2, 0. The multiplicities where there's none written, so it's an understood 1, 1, 1. Okay? And that's odd. And if it's an odd multiplicity, okay, it crosses. So all 3 of these are going to cross. To find your degree, you add up all 3 of these numbers right here. Okay, so I get my degree to be 3. Leading coefficient, there's no number there, so it's understood 1. We're going to skip this because we've already done it. Turning points is n minus 1, so it'll be 3 minus 1, so this will have a total of 2 curves. Okay? Alright, now this is where Desmos is going to come in handy. Okay? So you can look at this and find your zeros, but we're just going to use Desmos because you can use it on the exam. Alright, so the first equation is there in factored form. Alright, so I'm going to pull Desmos up. I'm going to type it in, okay, just how I saw it. Y equals x minus 1 squared, and then x minus 3. Okay, the things you want to get from your graph are your zeros first. Okay, now your zeros are where you cross the x-axis. Across the x-axis at those 2 points right there, 1, 0, and 3, 0. So go back here. So my x-intercepts. Okay, my x-intercepts, they are 1, 0, and 3, 0. 1, 0, 3, 0, which we could have got from there. Okay. Now, at 1, see how it has an even? Okay, and even's going to turn. You see how it turns? See how it doesn't cross at the even? So you see at the even when it just touches it? So at the even it touches, and at the odd it crosses. So I come here. So at 1 I'm going to cross, and at 3 I'm just going to touch. No, sorry, I got that backwards. Don't even touch me. That's what keeps me in line. So even is touch, odd is cross. Okay? Alright, so I'm going to plot a point at 1, 0. Then we'll plot a point at 3, 0. Okay? The y-intercept, your y-intercept is where it crosses the y-axis, which is right there, 0, -3. So my y-intercept is 0, -3. Let's change the color. So 0, -3. So I'm coming here to -3 on the y-axis and draw a point. All right. Next, it wouldn't hurt to get your max and your mins. Actually find those turning points. Okay. So if you look, I have a max here, which I've already written that one down because it's a 0, so that's a max and a 0. But I haven't gotten this point yet. Now it's a decimal. Graph it as best you can. So 2.3 and -1.2. So 2.3 and -1.2. 2.3 and -1.2. That's going to be a min. So I'm going to plot it best you can. 2 1/3 and then -1 and a little bit. Okay, doesn't have to be accurate. Now, if you look at the end behavior, it's coming from -infinity. See my cursor right here? Going to -infinity, and then it ends in positive. So when I draw this graph, I'm going to start in the negative, come up here, curve, 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 and end in the positive. Okay? That's really all you need to graph. All right, so the next one is going to be, let's graph this one. So this is p of x equals 1/12 times x plus 2 squared times x minus 3 squared. So we're going to use Desmos, because why not? Because you can use it on the exam. So now I'm going to graph this one. So it is, was it negative? No, it's not negative. Okay. So it's 1/12, so 1 divided by 2, 12. Gotta get out from that. So then parentheses, x plus 2 squared, and then x minus 3 squared. Alright, so you don't have to write y equals, but it's a really good habit to get into, okay? Sometimes I forget also. So the first one I'm going to look at is the y-intercept, where it crosses the y-axis, which is right there, 0, 3. So my y-intercept for this one is 0, 3. So let's plot that 0, 3. Then I'm going to find my x-intercepts next. Okay, remember x-intercepts are your zeros, your solutions, your x-intercepts, your roots, that's the other word. So my 0, 0, where it crosses the x-axis. It crosses at -2 and +3. So I've got -2, 0, and +3. Let me erase that. That's sloppy. And 3, 0. Okay. Alright. I don't know why I need to turn notifications off. Now, I can get that up here. The -2 comes from here. So that's an even. So don't even touch me. So that touches. Okay. And this one is also even, so it's also a touch, which you can also look at the graph and tell that it touches the graph. See right there how it touches? Touches the graph. Okay. Now, next, see if there's any max or mins. There's one gray dot left untouched. That is a max. So that is 0.5 and 3.3. 0.5 and 3.3. So 0.5 and 3.3. And that was a max. My other mins were my zeros, so I don't have to write those. Okay. Alright. So now let's plot these points. So my max is 0.5, 3.3, so it's just over a half, and then up 3 1/3. That looks good. And then plot your zeros. -2, and then 3. Now the end behavior, if you look, my y's are coming from positive infinity, and then my y's end on positive infinity. So I need to start in the positives up here, come down, scoop up, because it's don't even touch me, y-intercept, max, don't even touch me again, and then I end in positive. Okay? Alright, last one. Okay, so this is going to be x times x minus 3 times x plus 2. Right, let's go to Desmos, let's graph it. So it's going to be y equals x, and type it how you see it, okay? And then x plus 2. All right, so first let's get the y-intercept. Where's it cross the y-axis at? Well, 0, 0. So my y-intercept is 0, 0. Next, we're going to find our x-intercepts. Okay, x-intercepts negative 2, 0, 0, and 3, 0. So negative 2 and 3. So negative 2, 0, 0, and 3. All right, the negative 2 comes from right here, has a multiplicity of 1, so it's going to cross. 0 comes from the x by itself. We learned that from up there. That's a cross because it's got a degree of 1, a multiplicity of 1. The 3 comes from here, also has a multiplicity of 1, which means it crosses. And then last, see if there's any max or mins we did not click. So if you look, there's actually 2 here I did not click. Okay, so the first one is negative 1.2, negative 1.12 and 4.1. Let's see if I can remember that. So that was a max. It was, didn't remember, negative 1, 1.2. And then 4.1. And then I saw that there was a min. So the min is 1, right down here. 1.8 and negative 8.2. So 1.8 and negative 8.2. And that's all the gray dots. And then if you look, my y's start in the negatives and they end in the positives. So I'm going to start in the negative, okay, and follow my guidelines that I've written over here. Well, I hadn't even plotted the stuff. So let's plot 0, 0. That's a y-intercept and an x-intercept, so it's fine. You just plot it once. And then I've got negative 2, 0, 3, 0. Your max and mins are decimals, but just guesstimate them, okay? So negative 1.2 and then 4.1. And then min is 1.8, negative 8.2. All right, and I said my graph starts in the negatives. So my graph starts in the negatives, hits here because it's a cross, a max, cross, a min, cross, and I end up positive, okay? All right, so that is it for your video today. All right, and go check Canvas for what your assignment will be after this. All right, bye guys.